Next, we're going to talk about the point crossing the horizontal asymptote. Note that there can only be, at most, one horizontal asymptote. From the chart that we just talked about, there's only one horizontal asymptote that we can ever have. And also, the graph may possibly cross the horizontal asymptote, but never actually in the extremities of the graph. What does that mean? Well, let's take a look here. Here are two examples where we have a horizontal asymptote. The first one has a horizontal asymptote on the x-axis. Notice that this blue line gets ever closer and closer and closer to the x-axis, to that horizontal asymptote. In the extremities, in the very, very far right and the very, very far left, it's not going to cross that line. It's going to get ever closer to it, but not cross it. But right here in the middle of your graph, the graph crosses the horizontal asymptote. So in the middle of the graph, you might cross it once, possibly even twice, but it's kind of a rare case where it'll cross it. And we're going to cover a couple of those. But in the extremities, to the very far right towards positive infinity, and the very far left towards negative infinity, your graph will not cross your asymptote, but it could cross, you know, in the middle, kind of close to zero. And when I say kind of close to zero, it could, you know, still be, you know, plus or minus 100 even. When you're talking about infinity, close to zero is pretty relative. Okay, let's take a look at the next one. We have an asymptote right here, a horizontal asymptote. Notice the blue lines in the extremities, really, really far right, it doesn't cross. Really, really far left, it's not going to cross. But right in the middle, it crosses the horizontal asymptote once. Okay? So we need to know how to find those points where they cross. So the steps for that is to set the reduced function. Make sure you reduce the function first. If it can factor and some factors can cancel out, you need to do that first. And you're going to set that reduced function equal to the horizontal asymptote. The number there. And then we're going to solve for x. Now that x that we solve for will give you the x coordinate of the point. Okay, so we're talking whatever you solve for this, that's going to get you the x coordinate. The value of the y coordinate will always be the value of the horizontal asymptote. So what we're going to do now is we're going to scroll back up to the previous page and we're going to do those problems again, but this time we're going to find the point crossing. So on our first problem we have f of x equals x squared minus 1 over x squared plus x. We do know we have a horizontal asymptote at y equals 1, so to get the point crossing, first I have to look at the function and see if it can be reduced. It looks like it can. The x plus 1 reduces out, and so that gives me f of x equals x minus 1 over x. Okay, so this is my reduced function. Okay, so the rules say in order to find the point crossing the horizontal asymptote, I'm going to take my function, my reduced function, and set it equal to the horizontal asymptote value. In this case, the horizontal asymptote is at 1. An easy way to solve this is to cross multiply. I put the 1 over 1. I get 1 times x is 1. X minus 1 times 1 is x minus 1. And then when I solve by subtracting x on both sides, that gets me 0 equals negative, 0 equals negative 1. Well, that doesn't have an x in it anymore at all, does it? And 0 never equals negative 1. So therefore, I can say that there are no points crossing the horizontal asymptote. If you are trying to solve for x and the x value goes away, well, then there isn't a point that crosses. And that happens quite a bit. Let's try another problem. Okay, so in this particular function, it looks like I can factor the bottom. So I get 5x minus 2 on the top. In the bottom, I'm getting 3x plus 2 and x minus 1. Okay, but the top and the bottom, nothing reduces out. So in this case, the original function and this function are both the reduced function because you can't do anything there. So I'm going to set my function, either one in this case, because they're basically the same, because it doesn't reduce out, equal to my horizontal asymptote. And the horizontal asymptote is 0. So I put 0 over 1 and I cross multiply. The 3x squared minus x minus 2 times 0 is still 0. 5x minus 2 times 1 is 5x minus 2. When I solve, I'm getting x is equal to 2/5. So the point crossing the horizontal asymptote is 2/5 comma some value. Well, what is that value? What is the y value? Well, the y value comes from the horizontal asymptote. It's got to be 0 because that's where it's crossing the horizontal asymptote at y equals 0. So in this case, the point crossing is 2/5 comma 0. Okay, on this last problem, there is no horizontal asymptote, so therefore there can be no point crossing the horizontal asymptote because, well, there isn't a horizontal asymptote, so therefore you can't have a point crossing it. Next, let's go through the steps for graphing rational functions. The first thing I want you to do is find the domain. This is before reducing your expression, and the way I want you to do that is to set the denominator equal to 0 and then state your answer in interval notation. Second, I want you to find the vertical asymptote. Now, there might be more than one, that's why there's a little s there, it could possibly be one. The way we do that is after you reduce your expression, set the denominator equal to 0 and solve. Next, find holes, if any, by setting that factor that you divided out, if there was any, equal to 0, and solve. This will be the x-coordinate of the hole. In order to find the y-coordinate, you need to substitute the x-coordinate into the reduced function form. Step 4, find the horizontal asymptote. We do this using the chart. Step 5, find any points crossing the horizontal asymptote, if any. And we do that by setting the reduced function equal to the horizontal asymptote, solve. If there is a real solution, then the solution is the x-coordinate and the y-coordinate will be the value from the horizontal asymptote. Now, if there's not a real solution, then there isn't any points crossing the horizontal asymptote. Step 6, find the x-intercepts. There may be more than one. They're always in the form some value comma 0. We find them by setting the numerator equal to 0 and solve. Be sure to use the reduced form of the function. If it can reduce, then you need to use a reduced form on this part. There may be several. Step 7, find the y-intercept. This is always written as 0 comma some value. We find that by evaluating the function at 0, or in other words, just finding f of 0, there will only ever be one y-intercept. Step 8, plot the points and possibly even more points and the holes and the horizontal asymptotes, and then graph the shape. Connect the points with a smooth curve, and the curves need to approach the asymptotes, the horizontal and vertical asymptote.